questions from last lecture?
Which one looks like?
Oh, that's a good question. I don't remember that one. Should be the ones where we try to compare between switch and hubs. And we started with the beginning of the MAC addressing where we are defining a table. How can we forward an actual packet from a source to a destination? How do you create self-learning, the plug and play? And within switches, what does that mean? How do you create the filtering and forwarding? And virtual LANs. So, any questions? So hopefully we're covering like 90% of the material today. We're just reiterating whatever we used in that lecture. So let's start with the first simple thing. Why full duplex operation is not possible in bus series? Shared media environments. What do you think? Bus series. Which one is that? Which topology is that first? Remind me. So we first user connected in a bus series. So that's how it looks like. A connection between a huge sender and all the receivers. Why do I will not be able to have a full duplex? What do you think? Collisions, exactly. So the main issue of an actual topology in any network, collisions. How do I mitigate it? We use what we use? We said we use those multiple access control protocols. One of those 3 channels, 3 partitions where we have either the channel, we have the random access, and some other options. But with that, we still had collisions. And full duplex operation, we're a side of reducing the bandwidth because of the collision that occurs. So that evolved towards something else, towards what we call it the star topology, where we had either a switch or a hub as a main box, controlling those 3 nodes between them. So creating that star topology between other users. So for simplicity, because of collision, you cannot have a full duplex operation with a bus series connection. And therefore they try to move from this side of topologies towards the star topology. That's the first thing you need to know. What's a virtual LAN? What is a LAN? Before we jump to question number 2. Local area network. What is it?
It's a network between computers.
So it's in any topology connecting different hosts and different destinations, creating a network topology. So what do we use? If I try to use one of those star topologies, what am I going to use? It's an actual hub, or we called it the hub. There are 2 different things, hub and there is a switch. So let's stick with the switch a little bit as a more advanced device. A switch. So in other words, creating a LAN, a local area network, requires if I'm using the star topology, it requires a switch. So physical devices creates a local area network. What is a virtual LAN then? So before I go to virtual LANs, what issues do I have with actual LANs? So let's assume, yes.
Because it's a physical means, if someone from another department, simply for example, used wanted to then join a different local area network on a different part of the campus, for example, they would have to physically go there, plug in.
Most of you have seen, exactly that's the answer. But most of you have seen a switch, or at least a hub, which in an actual box has different ports. Each port is connected by an Ethernet cable to a different device, whether that's a Mac, a PC, a server, whatever that is. Each port has a number of users, one user to use, unless you use an adapter, creating 2 users on the same port, that's the issue, creating more ports within one port. So virtually that port holds number of users. If I'm trying to connect 2 different buildings, each one of them has its own switch. Or if it's a one switch, therefore this will struggle, because if you have different 2 departments and you're trying to send information from one department to the other, you try to do a broadcasting to a specific department, both departments will receive it if I'm using the same switch. So there are 2 things that are related to the problems within a physical LAN. One, dynamic membership cannot happen. What do I mean by dynamic membership? It's just what you explained. It's having that port, that exact switch with different port numbers. Let's just make it simple. 4 ports within one switch, and each one of them is being given allocation to a user. If I say this is, for example, computer science, that switch belongs to a computer science, therefore this can only be used by computer science because it's in an exact location or a building. People will say, okay, wait a minute, let's just divide between 2 users. I have a switch, let's say that room is an electrical engineering and this room is a computer science. So in other words, I'm giving port number 1 and 2 to computer science, number 3 and 4 to electrical engineering. But this will suffer from, you cannot isolate the traffic, because if I give those to electrical engineering, if I'm trying to do a broadcast, everyone in that hub or in that switch will receive the message. So I could not achieve that traffic isolation. That's not one of our goals. And what you mentioned, the dynamic membership, if it's in 2 different buildings and it's an actual hub here connecting 4 users, and this is a different hub for computer science and electrical engineering, if I want to be trying to move one to reside in number 4 here, he needs to take all his equipment, take it with him to a different building, different department, and try to actually fit it inside that port to have that capability on that LAN. So you might see those issues. So I'm trying to achieve dynamic membership, and I'm trying to achieve traffic isolation. Are these 2 terminologies clear? Dynamic membership, trying to give a port number within a LAN towards a different user, which is that how virtual LANs operate. Is actually, in reality, dividing it virtually into 2 different isolated LANs. That's your virtual LAN. It's a switch divided into multiple LANs. Virtually into multiple LANs. So assuming that this is your switch, that's virtually divided between those 8 users. In here, you can play with the actual ports. So you say, oh, we want to give 1, 2, 3, number 8 to, for example, electrical engineering. I want to give 4, 5, 6, 7 towards computer science. So in here, you achieve now at the moment your dynamic membership in addition to your traffic isolation. So people might say, okay, if I'm trying to send a message or broadcast to electrical engineering, in reality, only 1, 2, 3, and 8 will receive that message. That's your virtual LAN. It's creating the software over a normal LAN, creating that virtuality of an actual LAN. If I wanted to give port number 6, I've changed my mind and asked someone from electrical engineering to sit and reside here. I'll just configure it to sit within this port number 6 towards electrical engineering. Simple as that. So that's reality what dynamic membership means, and that's what it means by isolation of traffic. Should be clear. Very simple. That's how virtual LAN is achieving that 2 goals. We defined something else. We said if I'm trying to connect 2 different virtual LANs, therefore we need to configure an specific port we call the trunking port to connect it to a different virtual LAN. And these 2 ports, let's say call it A here and A here, both of them are left empty to connect those 2 virtual LANs. These cannot be occupied by users. They are used to actually traffic or connect those 2 virtual LANs. That's it. That's virtual LANs. So if I ask you now what, sorry. Yeah, I thought you had the question, sorry. If I would ask you now what are the capabilities of virtual LAN compared to a normal LAN, you should give me those 2 main points: dynamic membership, isolation of traffic. If I ask you to explain it, you should be able to explain them both of them now. Any questions? Should be clear. Question number 3. Why Ethernet is the most dominant technology in data center? We need to be careful that not only Ethernet is a technology within data link layers. There are other technologies we use, like the frame relay, ATM, and all of them achieving very good results compared to Ethernet. But why Ethernet was the most dominant, and until our days, Ethernet is used by everyone. Companies, universities, normal users, personal users, everyone uses Ethernet. Most of the devices are equipped to take Ethernet. Just look at that laptop. We should have it, or at least a USB give you a port towards many Ethernet ports. Why is that? For reliability. That's one of the criteria, but not the main criteria.
I think it was like all the ports are universal.
Yes, but why was that? So they were universal to fit your Ethernet. They were standardized to fit everyone else. But why Ethernet? Why not ATM, for example? Or coax? Sorry?
It was really cost effective.
First of all, it was cheap. For the first reason, it was very cheap when they started.
Nowadays, it's because within local area networks, there's going to be lots of Ethernet already installed and change it all within business. And it costs a lot of money.
Eventually, how did I reach that stage? I'll explain. But at the moment, other technologies are coping and had similar speed similar price, but yet not as popular as Ethernet? The answer is most infrastructures within the UK, within the world itself, use Ethernet, and they both use switches, hubs, your actual servers, PCs, Macs, whatever you're using, to fit and to be eligible to use within Ethernet technologies. Therefore, to change everything, even if it's cheaper now, it will cost them more money because the differences at the moment are very, very little. But how did they reach that stage? They were highly widely used since the beginning. They were the first technologies. They were coping with speed very fast. So even if I say, for example, if I try to compare a Google Nexus within an actual Apple device, you see them every year. They are trying in the beginning to cope with each other. Therefore, each one of them is trying to get up with the specification. Although Apple is not catching with specification, but Apple was the first dominant technology to be used within the market. Although people will disagree, say no, smart devices were used with other people, but marketing made Apple do whatever they want to do. So it might be the case of marketing of an actual device, but it was widely used in the beginning, Ethernet, and therefore they were a dominant technology. They are simple, very simple. You see the structure of the Ethernet, which I'll have the next question. It's very simple. I'll define it whenever we reach that. So it's simple, cheap, widely used, dominant, and will cost loads of money to actually change the actual technology to two different technologies. Questions? It should be logical. And if I give you something, if it costs you 2 million to create a company, and I then came after like 2 years saying that, look, I'll give you something else, much better speed. But I say much better is not that difference, but it will cost you like an extra 3 million. I don't want it. Most of the companies are in at the moment, most of the companies using hard equipment devices, like any storage company, an actual engineering company, creating, even go back to car manufacturers. Most of those devices are the same. They just upgrade some of the details to fit whatever they need. They don't change everything entirely, unless there are a shift in the technology where you need something entirely new. Okay. What is 10 base 5 Ethernet? What's that terminology? What's that mean? Let's give it, yeah, no. Should be fine, yeah. What's that? So, 10 base 5. First of all, you need to be clear that Ethernet is not only one option. How many Ethernets do we have? What defines an Ethernet? How do you define different Ethernets? What are the differences? If I would say I have 2 different Ethernets, what criteria they have different? What? Yeah. The physical connection between each devices will define one of your actual attributes, criteria. So if I use an Ethernet within a coax cable, and I use an Ethernet within a fiber optic as a physical medium, there are 2 different Ethernets. So there are 2 different options within Ethernet, starting with the normal coax cables, moving up towards the fiber optics. Each one of those physical medium has an actual acronym to be defined within the actual Ethernet name. So in this case, for example, that's one of the criteria. What else? If you change the cable, what will that result of? If I move from a coax to a fiber optic, what changes? Speed, that's the one. So if I say, for example, at the moment 10, I'm referring to 10 megabits per second. Simple as that. I've just said that we have a different physical medium. We have different signaling within every different Ethernet option available. And for example, base here means it's a baseband connection or signaling rather than, for example, a broadband. So again, I'm trying here to show you, or to make you proactive think that there is not just one Ethernet, there are multiple options available. And those multiple options can indicate the physical medium, the type of signaling, the speed itself, and what type of connection will be.
Would you say the baseband is it like broadband or it's instead?
No. There is a baseband, an option, and there is a broadband,
Okay,
like 1 and 2, either one of those. Again, that's some kind of signaling. For example, the 5 here means all those 5 base has 5 options of this type of 5 base. There is another one, another family of evenness. There's a family called, I think, 100, I think it's broadband TX, for example, which TX refers to something else like the fiber optic. So I don't want you to know every variant. I want you to know that those terminologies or those acronyms refer to an actual meaning, either speed, type of signaling, type of physical medium, and so on. There's no like one definition of those, but they are available. I don't want to bother you with the full details of them because there are books defining each one of those, and each books are defining. I think you remember the book I showed you that had big details, information of full LAN operations, and they are book that big, defining each acronym and what does it do and how can you have different options and different criteria. What I want you to know is there are so many types. That's it. Questions?
Would it say broad instead of basic? It was broad.
Sometimes it's broad, sometimes they say fiber optic broad. There are different names. I don't know all the names. I will not cheat you and say I will know them all. I might know 2 or 3 of those.
So it's always done in that kind of 3-tier structure. The first one's speed, the second one's a signal, and the third one's
Yes, in some sort of yes. Sometimes the actual signaling will refer to 2 things. For example, the signaling and the physical medium connection. Sometimes the end of it will refer to the base, the actual options within the family of that one. So you are just speaking of so many options within one family. Because when I say 10 base 5, so at the moment I haven't defined whether that's a star topology, I haven't defined it's an actual bus series, haven't defined, it depends on repeaters, hub, switch. You cannot put it in, but it's one of those options. Any questions? You seem to be understanding what I'm saying. So that's very compare between switch and hub.
How so stupid?
Exactly. Hub is a dumb device. But again, what does dumb device mean? You say dumb, what does that mean?
Know how to
So it's not self-learning, exactly. It cannot configure its own by itself. So you cannot bring a switch and hub in the actual room, and you have 4 different PCs, and you saw plugging in, and you saw using it. Sorry.
hub was, I think you said it was mainly just used to sort of cut down on that the wires you needed as opposed to.
It's a bus inside a box. So you see the first topology of drone? It's exactly the bus inside a box. So this is how a hub looks like in reality. Like your physical medium connection is just inside happening. Number of wires connecting those different ports. There's no technology behind it, just a black box of a different series connection. So if I bring a hub inside the room and I say let's try to have a network session, a gaming session, and then let's connect it, nothing will happen. You just have a complex of collision. And I cannot see you cannot see me. What's happening here? You need an admin to configure the hub between those devices. Simple as that. Meanwhile, switch, it's not like that. Switch are clever devices. They are self-learning devices. And we go back to that terminology and emphasize what this self-learning means. Hub has no medium access control within the actual box. It depends on hosts.
So hub to
The hub, yes. So every negative thing will be the hub, put it that way. It was the first technology. The first technology starting with the star topology. Then they moved towards the switch and so on. At the moment, we have some devices called hub. I think you came back to me saying that what's a BT hub then? Why? It's just a router. It's called BT hub. It's the name. The actual router with an actual switch capability. Every most dominant at the moment hubs, let's call them hubs, are routing switching capabilities. Unless the admin asks for a separate switch and a separate routing device for the network topology itself. I think we have switches within the university, but it's a specific request by the admins. I will not go into details of how they are running because I don't know. So, clever devices, you switch, dumb devices, the actual hubs. Hubs are not self-learning. Meanwhile, self-learning are your switches. Collision will not occur in your switches. They depend on, in the actual switches, you'll have a multiple access control protocol inside the actual switch that control the sending and receiving of messages, so there is no collision. Meanwhile, in hubs, you still have collision because medium access control are implemented in your end devices rather inside the box. Simple as that. Again, it's straight from the notes, straight from the book. You can see it there. I'll start with the Ethernet frame structure before I move forward towards the plug-and-play terminology, before I describe how do you create what this plug-and-play means in general and in the switch, and how do you create the filtering and forwarding process within the switch network. How does a frame structure, how does an Ethernet frame structure look like? I'll draw it and I'll ask you to describe the actual components or parts of it. So, Ethernet, something like that, have something in the beginning called preamble. What's that? To make things clear, it's very identical, or it's replacing the flags within point-to-point protocol. So what does it do?
That's where the message starts and ends.
It's an indication to where a message starts and ends, but not just that. That's one of its, let's say, operation parts. It's a 7 bytes field, which has so many other things within. But the main operation of an actual preamble is to synchronize the clock between the sender and the receiver. That's an important part. We're dealing with a high-speed type of Ethernet, therefore I'm dealing with 10 gigs. So how can I actually synchronize those two devices? I need that byte in the beginning. So I'll just say, for simplicity, synchronize the clock between your sender and receiver. Clocking those two devices with the same clock. I don't want to go into details, but in a matter of fact, it's just making both devices at the same page. Then when you send a message, you receive it in the other end without having to clock at a different time, because you'll end up with a delay or you'll end up with drop-off packets. What else do I have in a frame structure? I'll have something called address. What is address in here? So first of all, we're dealing with data link. So data link, keep in mind what kind of addresses we have within data link layer. Okay, but what are the kind of addresses? Do we deal with MAC addresses? Data link layer deals with MAC addresses, purely MAC addresses and only MAC addresses. That would be data link layer. Be careful, because we would need to know what are the differences between MAC and IP. In one stage, and I think in the next lecture or the lecture after, I'm defining something called address resolution protocol, where I associate between MAC and IP addresses, and how can devices talk with each other using those two type of addresses. So yes, I'm dealing with MAC addresses. So in here I have my MAC address. MAC address of what? I will have two parts of it, source and destination. That's very important in your self-learning process. I'll show you why later on. I have something here called type. I have data, and I'll have CRC. I'll ask you the questions. So, what do I have in my CRC? What is my CRC field?
Redundant check.
Cycle redundancy check, which detects to check for errors. What about the data? What's that? The actual data coming from?
Send.
Coming from the sender to the receiver, but who's in this case, where it's coming from in your encapsulation process? What's above your data link? The network layer. So it's coming from your network layer. In other words, this is your datagram inside the data. What's the type then? Final form.
Is that what it was broadcast or?
That's not.
What type of frame is?
What do you mean type of frame?
Frame.
No, don't go there. Sorry? Program? Protocol. Exactly, the protocol used by your higher layer. So in other words, I'm defining here your IP address. So I'm telling you that this is coming from network layer number 3, from the IP protocol, from the internet protocol. So defining your protocol, because there are different protocols within your higher layers. You need to know to understand what kind of operation is happening. when you send the actual frame. Because so IP address don't provide you a reliable service. It depends on your TCP. So you need to know, am I delivering a reliable service? That type is important. Okay, I'm trying to emphasize here on your address. Because the next question is, explain plug and play. So let's explain plug and play in general. That's a very usable term within everyone, within networking, technologies. Everyone should know what this plug and play means. What does it mean? Self-configuring device. If I use a USB stick and try to put it in a PC, the PC should have the driver of the actual USB stick. Therefore, it understands what's just came inside this device. So it will know exactly what kind of stick, what's the size, how to send information between the operating system or the physical device and the actual stick. So everything is done in milliseconds because the operating system knows. Even if the operating system did not define it, we are using an old version. It should by nature go to the internet, try to fetch the actual driver, update the device, and then allow you to use it. It will take longer, but it's nothing to you doing it. Unless it's a manual thing, therefore it needs configuration. So that's a plug and play term within a general perspective. What does that mean within the switches then? Self-configuration, but when we said the stick, it's trying to know the driver. When I say switch, what does the plug and play self-configuration mean? So exactly what you're saying is, first of all, what does a switch do? Before you say that two parts, because you skipped one part to make it clear. What does a switch do?
Takes the information forward.
Just forward the message from a source or its destination, or from an incoming link to an outgoing link. So let's just remind yourself, let's consider this as a switch. A connection here is when I'm sending information from A, the switch main goal is to pass it on towards the destination. So, self-learning. What do you need to create that self-learning? You need a table. You need a switch table to create that actual learning. What do you have an entry within a table? So I'm trying to do self-learning. So first of all, that switch table consists of different rows and different columns. First of all, that table is empty. If I'm doing self-learning, that means I bought a new switch, put it inside this room, and I said, okay guys, let's connect. So the switch table by default is empty, doesn't know anything about anyone. How will the self-learning happen now? Give me the process.
If you want anyone to send to say B down the bottom, if it doesn't know the address, it will broadcast the switch.
No. Step by step, don't jump to step number 4 if you just write number 1. Right. So first of all, you said A.
Yeah.
We said switches usually have ports.
Yeah.
So the ports we call it an interface. So usually you have a port number indicated within your connections. Each port has an interface. You said each port has a user. So you cannot create a port within 2 users.
I was going to say that. But
Yeah, eventually. Yeah, well, I'm doing that for a reason, to differentiate between self-learning and forwarding and filtering. That's why I'm trying to be picky here. So yes, I'm sending that message. What does that message has? Returning to the structure of the actual Ethernet. What does it have?
source and destination.
Perfectly. So they have a source and destination. They should be in MAC addresses. But for simplicity, I'm just going to call it source A trying to send to B. In reality, this should be, by the way, like an FF, E5, 48 bits. But for simplicity, I'm just calling it A and B. Okay? So that message, I'm sticking with you. That message is now reached. So A doesn't know anything. He wants to send it to B. He doesn't know port numbers. He just wants that message to arrive to destination. He tried to send an email to your friend. He just have his destination, his email address. You don't care where exactly he's residing, whether in the UK, whether he's in Germany, and you don't care. So you send that message, arrive to the switch. What will the switch do?
You remember which port it came in on as well.
So perfectly. So that means you'll have your MAC address, you'll have an interface, and you have something called a timer, and we'll explain why you need a timer. So an interface. Okay, so first of all, the message came, you've read the message. You've tried to process it. So he know that the MAC address, he enters what? As a source. So he put A as a source because he knows A is associated to an actual interface. So he put interface number 1, which came in at 9. Say make it that way. What will he do? So at the moment, self-learning is only associated with the switch reading or processing the actual frame. That's it. So if I would say self-learning, you should stop by now. Don't do anything else. Don't flood the messages. Just say that's self-learning. An actual switch depends on, creates an entry depending on the source and the interface and where the frame came from. That's it. Okay, what the rest then? Tell me the process. If I'm trying to send from A to B, so at the moment, explain to me the other part of the question, the process of frame filtering and forwarding. Now let's leave it, because we've been over the other one. So now, that switch, that frame is residing in the switch, and the switch is trying to think, I want to forward this to as a destination, which is called B. What will I do? He'll look at the table, and he sees there is no B. What will he do? He will broadcast. That means he's sending the same message to those 3 users. So each one of those users will receive that same message. Who's the only person who will receive that message and keep it? We're not talking about security. Purely just people are here very polite. You're trying to hold a message. That's the human nature. You receive a message not for you, you just want to open it. And that's the same with networking. So this is intended to be delivered to B and only B. So if he matches his own source with the actual destination, he says, that message is for me, I'm keeping it. So those should drop the messages because the source doesn't match the actual destination. Clear? First step. By the way, nothing happening in the table. You're just trying to forward the message to a destination. So now B have received the message. Let's, for a pure example, say B wanted to reply to that email. He wanted to send the message back to A. So how does that message look like? This is your same message. He's trying to send a new message. What will the source say? Destination. So he's trying to forward that message to as a destination. So he sent the same message back to the switch. By the way, the switch is transparent. You never know there's a switch in the middle because there might be millions of switches or just one switch. Or there's no switch at all. You don't care. You just want your message to arrive to as a destination. That's your pure goal. That's it. The same message arrived to the switch. What happens? Being processed. So you check what? You check the table. What he will do first. So he will do the self-learning thing again. He's trying to write down where did that message come from and what's the MAC address. So you see right B coming from port number 3 at 9:05. Again, self-learning. He tried to send it to a destination. In this case, he's looking for the destination field. What does it say? It says A. Do I have an entry for A? Yes, I do. Which resides on port number 1. He just forwarded that message to his destination and that's it. Finished. Well, so very simple. Self-learning means I'm depending only on the actual source within my frame to create an entry. Meanwhile, an actual forwarding and filtering of actual messages to a destination, it depends. If I have an entry for the destination, I'll just send it directly to that destination. If I do not have an entry, I'll flood the system with an actual broadcasting message of that frame. Again, it's not ideal to actually always try to flood the system because that creates overhead. So that's why we need other ways of addressing to reduce that ambiguity between where are they residing, how can I send it to them. That's why we need IP addresses at what stage. Because IP addresses have 4 different octets and each octet is defined. When I say octet, it's that field, like 225, 225, 8192, for example. Each one of them is on 8 bits, so therefore they are explaining details of how can I reach my destination. The thing I skipped here is, what's the timer? What do I need the timer for? Yeah.
So that I think one of the destinations or sources changes and then nothing is no longer there if it drops it after a certain amount of time.
So the timer, in other words, is the time to live. So it's the actual time you allow an actual member or an actual entry to stay within that hub because without that table, because we are dealing with not a finite number of actual users. So you don't want to have that X number of users using the network and then leave it there and unactive. you'll reach a stage your actual table is full. You're gonna have no entries. Just imagine, just to give you a good example. We're sitting in the actual wireless at the moment within DMU. You're trying to use a wireless system. It gives you access, and you just use it for like an hour and went back home. How long will that credentials be stored in your actual database? There's a specific amount of time for those credentials to be there, because you are an active user. For after a amount that expires and that get deleted. For example, we say 60 minutes the time to live. This will be deleted, and it will be deleted if there is no activity with user number A from port 1.
If within the time that it's allowed to live, someone changes, say, port 1 is changed from A to D, and then they send a message, does that then wipe out what's on the table and replace it, or does it add it on?
It doesn't consider it as an old user. So let's say if there's a new user came in called D with the same port number 1, and that's been a new entry out to 910. This has an hour. It doesn't do anything. It's wait for it to expire by its own, because you might be sitting there and just plugging different switches and trying to play tricks. That's crazy, but again, it might happen. Trying to practice. So yes, it doesn't do anything unless it spends an hour, dies out, or just expires. As ridiculous as it sounds, it happens. Don't know why. You just imagine you have 2 ports and you have 3 users. No, you have a PlayStation, you have an actual PC, and you have a Mac. Well, you have a port with the 2 ports only. And you cannot have this wireless connection. You want to have full speed, because we know wired connection is faster than in wireless. So in other words, you want to use that wired, but your sister is sitting there trying to use it, but you cannot use it. Wait for her to go, and then you just plug it in. And then you have a new entry, although the first entry is not being deleted.
Does it always start and store the last time that it was used on?
Yes. So whenever you, because what does an update mean? It means that you're sending and receiving messages, and whenever you do update.
I wasn't sure, for example, if say then A comes along afterwards, does it then store A1, 9, 11, or does it just update the first one?
That's a weird frequent of numbers, but what he just said here is that user not being used, but used by someone else, but afterwards it came back up here. So it doesn't make any difference. It's not the priority thing. It's just storing details.
And that's so you can have like multiple switches plugged into each other. That's why kids are in.
Yeah. So what you're mentioning is that you'll have more than a user within one switch, therefore that's fine. But the question is this enough to deliver messages from a source to a destination? It is enough, but it's very slow. It is creating overhead. It is creating more flooding. We need to have more specific, or at least more precise type of messaging or addressing, between your source and destination. If I would now say, I had a question in the last lecture saying that why would I just depend on an entry within when I ever send an information? Why do I not do it when I receive an actual message? In other words, why do I not write down inside the frame something here saying that, write me down, for example, port number. So in other words, you have a port number of the source, port number of the destination. Can this happen? And why? So rather than just having source and destination, I want to know the port number inside the switch. Would that work? And why? Yes or no? No, that's not the reason. It's first of all, does it work or not, and why? Can I put 1 and 2, like associate users with interfaces? Exactly. How would you know which port you are on first? And how would you know, how are you know the destination? For example, you residing on port number 3. So in other words, I'm saying you, I live in Leicester, LE1, and my friend lives in LE6, and I want to send him information which he resides in port number. Seriously? I don't know my mobile number. How would I just remember all those details? So in other words, I'm creating overhead on myself, and I'm creating overhead on the actual frame, and therefore you're creating so much mess. This cannot happen. Simple as that. Unfortunately, whenever you try to make devices clever, we reduce our amount of thinking in a sense. You just depend heavily on the machine, but it's not always good to what you wish for become true, because if you leave everything to yourself, you cannot send messages depending on your information. You want to have it configured automatically. Everything is moving towards a pervasive, automated, context-aware type of environment, rather than I'm going to do it myself. Simple as that. That's the nature at the moment. Intelligent systems, the Internet of Things. So that's the new trend. Why would I create more overhead myself? I just want to make it more clever. I'm not going to bother you with those nonsense things. I'll just say, any more questions? Should be clear. Next lecture will be network layer, and we will describe IP addressing, and I'll describe some beginning. It depends how long it will take. I'll describe routing algorithm, Dijkstra algorithm. Thank you for your time. And can I have the register?